Hi, I'm Justin Stallings. I'm with Rohde Schwarz, and we're exhibiting here at the ION Navigation Show 2012 in Nashville, Tennessee. We've been around for over 75 years as a test and measurement company, but only recently have we begun to produce products in the GNSS world. Today we're demonstrating the SMBV 100A, various applications and new features that we're showing. This includes hardware-in-the-loop testing. This includes obscuration, vertical obstacles, testing your receivers under extreme circumstances to make sure that when they're in the line of duty, you can depend on them. Now, the SMBV is not only a GPS simulator, it's also a general purpose vector signal generator. You can use it for many different things, not just GPS simulation. You can simulate signals up to 3 gigahertz in frequency, levels down to -130 dBm, and you can simulate interferers, jamming. You can even simulate cellular network standards or Wi-Fi or Bluetooth, anything you need to do, which is very useful in this age of multi-technology devices. So this is our hardware-in-the-loop demonstration. Again, the SMBV is a signal generator that can simulate the GPS constellation. And in so doing, we can also simulate receiver points over time. In hardware-in-the-loop format, we can update the receiver in real time and display it up on our Google Earth here. So here we're at the Indy 500 race course. And what's happening is, through this joystick, we are sending commands to our simulator in real time that updates its position. The receiver takes its position and updates it on Google Earth. And so we get this real-time loop here. This setup is our obscuration setup, where we're modeling vertical obstacles. Think of, for instance, skyscrapers in New York City. And we have a receiver that's moving around in a rectangle around these buildings. And the satellite constellation, which is on the big screen monitor, as the receiver moves around a corner or moves across an intersection, these satellites will come in and out of view depending on the view down the street. So in about 20 or 30 seconds here, we'll round a corner and then you'll see something change in the satellite constellation. Some will turn blue and maybe go off to red, and other ones that are red will turn green and come on. So we're here, and when it comes to this street corner is when you'll see some things here and here change. So we're approaching the intersection now, and you should see some changes in the constellation just briefly. You see some turning green, some will flash on and off, blue, back to red. Below the constellation, you see the constellation, the satellite power over time. You see one of them has a little spike of green in it. That shows that it turned on briefly as we went through the intersection, but now we're behind a building again and it went away. So that's obscuration. We have to test all our receivers under these types of conditions to make sure they work in these kinds of environments. For more information, please contact us on our website at www.rohde-schwarz.com.